Suppose that a stone is thrown upward with an initial velocity of 88 feet per second, which is 60 miles per hour, and is released 8 feet above the ground. Its height h in feet after t seconds is given by h of t equals negative 16t squared plus 88t plus 8. A. Graph h in 0, 6, 1 by 0, 150, 50 window. B. When does the stone strike the ground? C. After how many seconds does the stone reach maximum height? Estimate this height. So we have our formula h of t, and that's equal to negative 16t squared plus 88t plus 8. To do it on the graphing calculator, we would go to the equation editor where we would enter in the y sub 1, and the way we have to enter it is negative 16x squared in place of t plus 88x plus 8. So let's go enter that into the calculator so we can take a look at its graph. So to graph this on the graphing calculator, we press the y equals, which is the equation editor key. That gives us y sub 1 equals. We enter negative 16, the x variable key, followed by the x squared key. So we have negative 16x squared plus key 88, the x variable key, and then plus 8. We were told what viewing window to use, so we press the window key and now adjust the window. The x min is supposed to be 0, so press 0 and enter. X max is 6, press enter. The scale is 1, it's already there, so we press enter to move down to the y minimum, which is to be set at 0, press enter. The maximum 150, press enter, and then 50 as the scale, press enter. Now we can graph this, so press the graph key. You'll see it's a parabola that opens down. Notice that when we look at this, it's starting up along the y-axis, and that makes sense because we are starting at a height of 8. It does intersect the x-axis way over to the right. So now let's go to part B of this problem. B, we want to know when does the stone strike the ground. And that means that we would solve the equation replacing the height with 0, because that's when the stone would hit the ground, when the height is 0. So we would have 0 equals negative 16t squared plus 88t plus 8. We're going to have to use the quadratic formula to solve this. So in this case, A is equal to negative 16, B is equal to 88, and C is equal to 8. So using the quadratic formula, we have x equals negative B, negative 88, plus or minus the square root of b squared, which is 88 squared, minus 4 times A, which is negative 16, times C, which is positive 8, and all of that divided by 2 times A, which is negative 16. Simplifying this, we get x is equal to the negative 88 plus or minus, underneath the square root, 88 squared is equal to 7,744. We have a negative times a negative, which means it's positive. 4 times 16 is 64, times 8 is 512. And in the denominator, negative 32. Well, if we were to enter all of that into the calculator, we would have to enter negative 88 plus the square root divided by negative 32, and that will give us one result. And we would have to enter in negative 88 minus that square root divided by negative 32. The two results we get are x equals negative 0.089. Let's examine that. Well, that refers to, when we're solving for x, actually a time. And so therefore, a time that's negative does not make sense. The other value of x that we get, x is approximately equal to 5.6. And what that means is after 5.6 seconds, this stone would hit the ground. For part C, what we're interested in is finding the maximum value. Well, we already have the graph of the equation, and so what we do is press second and then calc, which is the same as trace, and you'll see that choice number 4 is maximum. So I press 4, and it's asking what we want to use as the left bound. Now, the left bound needs to be to the left of the maximum. At the moment, it's not, so let me press the left arrow key a few times to get the left bound clearly to the left of that maximum height. Now I can press the Enter key. It's asking us now for a right bound. And of course, the right bound needs to be to the right of the maximum, so let's press the right arrow key a few times, or just press and hold it down. And now it's far enough over that I press Enter. It wants us to guess what the maximum is just by sight. So let's move closer by pressing the left arrow key to approximately where the maximum height occurs. Press the Enter key, and it will do the calculation telling us that the maximum is at 2.750005 for the x value, and for the y value, it's equal to 129. So what that's telling us is the maximum height is 129 feet at a time of x, which is in this case t, approximately 2.75 seconds. So let's write that down. All right, so let's write that solution. That means the maximum height is 129 feet, which occurs at 2.75 seconds.